Alright, here's my video on logistic growth. I'm only making this because Landon suggested that I make one on this topic. I'm just going to give you the quick and dirty facts on this. Logistic growth model is something that you should have covered in pre-cal. It basically, the shape of the graph looks like this, where this is the carrying capacity. T. Half the carrying capacity is where it grows the fastest, always. And it's generally in this form on the AP test. And the carrying capacity is often what number will make this part go to 0. I'm gonna kind of do this backwards. I'm gonna do the AP question. Go ahead and flip to the last page, and let's do this free response question first. So I can really show you what you really need to know for AP. Logistic is not a big topic. There are certain things they expect you to know, and if you know these things, you'll be good to go. In a nutshell, it says a population is modeled by a function P that satisfies the logistic differential equation. Here, the 12 is our carrying capacity, because if we look back at our equation, it's Kp 1 minus P over K, where K is the carrying capacity. So if I was to graph this thing, it would look like this, and this would be 12. So if P of 0 is 3, what is the limit as t approaches infinity of P of t? It's 12. If P is 20, it's still 12. If P of 0 is 100, it's still 12. It's going to be 12 regardless. As long as this is a 1, it's what number that if you fill in for P is going to give you a 0 right there. Well, if I fill in, because it's where the slope hits 0, it's where the slope of this thing levels out, because remember dp dt is actually the slope. And for logistic, they usually will use a logistic equation, like for instance with predator-prey type questions. It's like population. Like if you start out with 2 rabbits, and they're on an island. Forget the predator-prey thing. I can't come up with an example for that. If you got 2 rabbits on an island, on a very small island, they populate. They mate, and they have baby rabbits, and the population increases until there's no more room for the rabbits on the island, and it's going to level out. So the carrying capacity would have to do with the size of the islands in relation to the rabbits. Or if you introduce a new predator into a population, and you've got, like, I don't know, you throw a tiger and packlet, it's a bad example, and it's going to thrive, and you have two of them, and they're going to eat people until they run out of people to eat, and then their population will kind of level off. That's what the logistic equation does. It's kind of weird, but that's irrelevant for this particular thing, because this doesn't even give us a scenario. So it says if P of 0 equals 3, for what value of P is the population growing the fastest? The population is always growing the fastest at half the carrying capacity, so it's 6 every time. Logistic for AP is not that bad. It's one of the easier topics. Now C, this is where some of you are going to have trouble. It says a different population is modeled by a function y that satisfies the separable differential equation dy dt equals y over 5 times 1 minus t over 12. Find y of t if y of 0 is 3. Okay. So I need to separate and integrate. I'm going to rewrite this as 1/5 y times 1 minus t over 12. Can I multiply both sides by dt and divide by y? So I've got dy over y equals, I'm going to go ahead and distribute my 1/5 to make life easier, 1/5 minus t over 60 dt. I'm going to integrate. That is the natural log of y equals 1/5 t minus t squared over 120 plus c. Don't forget your plus c. Not naming any names. Avery, Jacob, Clint. Then let's go ahead and fill in and solve for c. I like finding my c first. You may not, and that's fine. Natural log of 3 equals 1/5 times 0 minus 0 squared over 120 plus c. C is the natural log of the absolute value of 3 is still 3, so it's the natural log of 3. So I'm going to go ahead and plug that in. Let's see, to here. So I've got the natural log of y equals 1/5 t minus t squared over 120 plus the natural log of 3. I'm going to e it both sides. Gosh, what is going on? That's gone, so that's absolute value of y. E to the 1/5 t minus t squared over 120 plus natural log of 3. This e to the plus natural log of 3, I could actually rewrite this thing with the times e to the natural log of 3 right here. The natural log and the e will cancel, and it's going to move to the front. It's going to be 3 e to the, let's go ahead and write that as t over 5 minus t squared over 120 equals the absolute value of y. Now I need to figure out if it's going to be plus or minus. Well, my initial condition has a positive value. So in order to give me a positive 3, it's going to have to be plus. If this is 0 and it's 1, it's going to have to be a positive. And that was part C. Part D asks me for the function y found in part C, what is the limit as t approaches infinity of y of t? As t approaches infinity, let's look what happens. This is part D. The limit as t approaches infinity. I'm going to write this a little different. 3e to the t over 5. Let's see. Okay, I had to remember what I was trying to do. Over e to the t squared over 120. As, what's bigger, the bottom or the top? Because minus goes with divide. I was trying to decide what I wanted to do in my 3, but it doesn't matter. The bottom's bigger than the top, so that's going to go to 0 as I'm going to infinity. Alright, so that was the free response. I'm going backwards, and that's okay. That's just the way I wanted to do it. This is called the exact solution. If we solve this thing, separate, integrate, solve for dp dt in terms of t, solve for p, this is what we get. If you want to see that happen, watch that video. Okay? If not, it's perfectly fine. Here's a typical question that has to do with logistic. It says, biologists stock a lake with 500 fish and estimate the carrying capacity to be 10,000. The number of fish tripled during the first year. We're actually going to use this equation here to do that. And it tells us that A is K minus the initial population over the initial population. So let's just go ahead and, well, let me finish reading. Assuming that the size of the fish population satisfies the logistic equation, find an expression for the size of the population after 2 years. I need to figure out my K and my A and my little k. So let's find K first. It gives it to us. K is 10,000. That's my carrying capacity. If you want to know what these are, here's the explanations. K is the carrying capacity, which is 10,000. A is the carrying capacity, 10,000, minus the initial population, 500, over 500, which ends up being, I figured this up, what is it? It is 19. Okay, so my equation is going to be P of T equals K, 10,000, over 1 plus 19 e to the negative kt. Now I need to solve for K in order to find an expression for the size of the population after 2 years. To solve for K, we fill in what we know. It says the number of fish tripled during the first year. So if it tripled, then how much do I have? What's my population? Well, if I started with 500, what's that telling me is that at 1 year, it tripled. So I would have 1,500 because I would multiply the 500 by 3. So I'm going to fill in my 1500 equals 10,000 over 1 plus 19 e to the negative k times 1, so just negative k. Now I got to solve this. A couple of different ways to solve it. If you want it solved a different way, watch this video. I'm doing this for you, Landon. Let's see, cross multiply 1 plus 19 e to the negative k equals, times 1500 equals 10,000. I don't like my k on the bottom, so I'm getting rid of it. Divide by 1500. So you got 1 plus 9, and I'm going fast. If you need to pause, go ahead. 10,000 divided by 1500. I did that already. It's 20 thirds. Minus 1, minus 1. 19e to the negative k equals 20 thirds minus 1 is 17 thirds. Minus 3 thirds. Yeah, 17 thirds. Divide by 19, divide by 19. And I went ahead and got a decimal. Really probably shouldn't, but I'm thinking this is definitely going to be a calculator question. It was let me look on my calculator. It was 0.2982. Ow. That was me dropping my calculator. So then we will take the natural log of both sides. Negative k equals the natural log of 0.2982 and divide by negative 1, and you get k to be 1.2098. And then assuming, so my equation is going to be, I'm going to fill this back in there. So the expression for the population is 10,000 over 1 plus 19e to the negative 1.2098 t. Now what we're going to do is we're going to save the rest of this and do it tomorrow. Okay, this is all the video that you need to watch tonight. We'll do B tomorrow. We'll do example 2 tomorrow. We'll do all those multiple choice questions tomorrow. So that's it for tonight. Whoops, I need to stop.